Am I audible, sir?
Yes, sir.
Yeah, thank you.
Hi, Milan.
Hello, sir. Yes, sir. Yeah. You can start. Maybe some 11 participants have joined. Yeah, we can just wait for 5 minutes, then we can start.
Okay, sure. So have you given them the context of this talk, this session?
Yeah, not record because I am presenting today.
Oh, okay.
So I am presenting, so not record.
Oh.
Sir, am I audible?
Yes, you are audible. Vijay Lakshmi?
Sir, am I audible, sir?
Yes, you are audible.
Ma'am, you are audible, ma'am. Okay. She told him something. I understood. Start பண்ணுங்க. Okay.
Dear participants, good morning all. Now I request Dr. Vijayalakshmi ma'am to introduce about today's speaker. Over to you, ma'am.
Good morning to all. Welcome to the third day of Global Initiative on Academic Network Program on a framework for interoperable blockchain to streamline supply chain communication. I would like to introduce our today's resource person, Dr. Malay Kumar Nath, who is going to deliver about the blockchain for deep learning. So Dr. Malay Kumar Nath has completed BE in Electronics and Telecommunication Engineering from Biju Patnaik University of Technology, Odisha, India in 2003, and MTech in Electronics and Communication Engineering from IIT Guwahati, India in 2008. He has completed his PhD from IIT Guwahati in signal processing. Now, he has been working as an assistant professor in the Department of ECE, NIT Puducherry, Karaikal, India, since July 2013. He was seconded to the Asian Institute of Technology, Bangkok, Thailand, by the President of India for teaching error control coding in 2018 for 1 semester. His area of research is machine learning and image processing. He has 25 publications in reputed SCI journals and 25 in international conferences. He has successfully completed 2 funded projects. He has supervised 2 PhD and 5 MTech scholars in signal processing. Now, I request Dr. Malay Kumar Nath to start the session. Over to you, sir.
Thank you, Dr. D. Vijayalakshmi, to introduce about myself. I hope I am audible to all of you. So today we'll talk about blockchain for deep learning. So the main of this blockchain-based deep learning solutions for various application areas. And here we'll talk about data analysis, provenance of data AI models, as well as we'll talk about model prediction, disease classification, combined cooperative positioning, crowd sensing, as well as crowdsourcing, channel protection, computational offloading, utility-based blockchain in security, etc. So I have planned my talk like this. So I will first discuss about these introductions, followed by the neural network, machine learning, deep learning, as well as how blockchain can be applied to this neural network, as well as machine learning applications. And we'll look into some of these application areas, as well as research challenges. What are the research challenges basically we are facing, and how we can overcome these challenges. So if we look into the introductions about deep learning, basically this deep learning is a concept which is coming from this neural network. And today's world, it gained popularity in informed decisions. So if you look into this deep learning concept, mainly based on centralized servers, and due to this centralized servers, this is has limitations of single point failure problems. So this centralized servers fails to provide operational transparency, traceability, reliability, security. And due to these centralized servers, this is prone to a single point failure problems. So at the single point, we can or failures are occurring in due to these centralized servers. So the aim is to importance of the integration of the blockchain with the deep learning. So if you look into the categorizations based on 7 parameters, that is blockchain type, deep learning models, deep learning specific conscious protocols, application area, services, data types, as well as deployment goals. So the aim is to discuss about this blockchain-based deep learning framework by highlighting their strengths as well as the weaknesses. We can compare the existing blockchain-based deep learning frameworks based on certain parameters such as blockchain type, conscious protocol, deep learning method, and the databases. We look into the research challenges that need to be developed a trustworthy deep learning framework. If we look into the application of a deep learning, it has a numerous applications starting from these industrial sectors to health sectors. If we'll consider one of the particular example of this health sector or healthcare sector, basically it is used for diagnosis, or it will help in classifying certain diseases from the patient by looking into the symptoms. Take the case of cancer detection, or take the case of COVID-19 predictions, or we can take the cases of the tumor detection from MRI images, etc. If we look into one of this particular example where this blockchain as well as deep learning is popularly used, that is called your COVID-19. So in this case, we can able to predict the disease spread in a particular region and how it helped the authorities in managing the pandemic using the forecasted result. So basically, this deep learning plays a very vital role in classifying the COVID-19 from the CT or from the X-ray images, as well as it also helps the authorities to managing the pandemic situations. This application of a DL is also popularly used in case of by the security personnel. So basically, this security personnel use this deep learning to identify the banned items that is present in the luggage during the travel time. So identifying the person using biometrics. Basically, when we are talking about biometrics, this is the unique feature, or we can say the unique representation about the persons. So by means of which you can able to identify the persons. Also, few of them are face, fingerprint, speech, and we'll talk about some of the few of the applications and many more in the latter slides. So if we look into the efficiency of this deep learning, this efficiency of deep learning mainly depends upon the quality of data and how we are getting a quality data. If we will not get a quality data, TL uses a centralized storage which is prone to a single point failure. So if we'll look into a data alteration that leads to the corrupt the model, as well as that leads to the misclassifications. So this is centralized storage leads to the single point failure as well as corrupt of the data, and due to the corrupt of the data there is a misclassification or erroneous result will occur. So the main aim is to improve the accuracy or improve the performance of this deep learning model is based on the quality of data, how we can able to get a quality data for our purpose or for making this system to be more effective. So if we look into the blockchain in contrast to this deep learning, so this blockchain is nothing but the decentralized technology, and as already Professor Dr. Vidyasagar Poddar already told, so this blockchain is efficiently handle data integrity, security, as well as confidentiality. So this blockchain, if we compare this blockchain with deep learning, so one is a centralized technology, another is called your decentralized technology. So blockchain is a decentralized, and whereas this deep learning is a centralized technology. So if we'll integrate this blockchain with this deep learning, so then we can get many more benefits out of that. So if we look into the benefits, it's numerous. Here I have noted down few of these benefits that is automated as well as trusted decision making, efficient data market management, data security, better model building for prediction purposes, model sharing, and enhancement of the robustness of the deep learning based systems. So this deep learning as well as data collection basically very, very important to improve the performance of these deep learning models, because the performance of these deep learning models depends upon this data. And whenever we are talking about these data collections, basically this data collection involves in data acquisition, labeling of the data, improvement of the data. So whenever we are talking about this labeling as well as improvement, we have to make which data is belonging to which class or which group. And whenever we are talking about the improvement of the data, basically we have to remove the noise, we have to remove the outliers, or we have to improve the contrast, etc. So basically this data plays a very vital role to improve the performance of this deep learning model. So whenever we are talking about this data collections, we are looking for a huge data, or we are looking for a large data, because this deep learning concept is very, very data hungry. So we can use the diverse data. So high quality training data from various resources is the important criteria to improve the performance of this deep learning model. So if we look into the less data, then what will happen to the system, or what will happen to this deep learning model? If we look into the less data, basically we are landing into overfitting of this model. So that means what exactly this overfitting of this model represent? That means the training accuracy as well as testing accuracy performances are very high. That means there is a huge gap between the training accuracy and testing accuracy. So we can say that due to the less data, where performance is also degrading. So the limited performance on the testing data, the quality of the algorithm is get affected. So we'll talk about this overfitting of this deep learning concept in the subsequent slides. So if we look into the application of this deep learning, so it has numerous of applications, and it is mainly used for image recognition. If we'll talk about this image recognition, in image recognition, we are analyzing the image, we are interpreting the image. Whenever we are talking about the interpretations, we are performing the work of classification, we are performing the work of detection. That means a particular region is get detected, or particular thing is get detected. When talking about the segmentation, we are talking about the region of interest to be segmented out. So this is the case in case of your image recognitions. Next, we'll talk about the sensory data analysis. Whenever we are talking about the sensory data analysis, the two important things coming to our mind, one is called your biometric. And when we are talking about the biometric, everybody will aware of that is fingerprint, iris, or that is called any kind of ECG data or any other data which are used for analysis point of view. And another data that is coming to our mind, that is wearable device. Everybody is using wearable devices to know their heart rate, pulse rate, to know about the health condition, or we can know about the blood oxygenation level, etc., etc. So this data to be analyzed. So this is mainly used by this deep learning. So next we'll talk about this OCR, that is called optical character recognition. So data from the scanned images, documents, or that is called photos, or whatever we are taking. So that has to be analyzed, and the required information to be segmented or to be found out. So intelligent data. If we look into the intelligent data, we are getting many data, we are getting large amount of data. How we can compress the data? We can compress the data so that the important information should not lost. Or if we'll talk about the healthcare systems, the diagnostic information should not lost. And we are talking about data gathering. So how we can cluster the data? How can gather the data? So these are the talk about this intelligent data. Next is the voice application, which is one of the most important when we are talking about the Alexa. How this Alexa is working on the principle of a person's voice to perform a particular kind of work. There is another thing that is called Cortana, which is developed by Microsoft. It is nothing but the intelligent personal assistant. So this is the very popular application of this deep learning. Next is called the text prediction. This text prediction represents whenever we are typing something by the help of Gmail or WhatsApp, what is the next text that can be predicted from the past samples, or that can be predicted from the previous text. Or we can say in another way that the text from the previous input can be predicted. So that is one of the popular application of this deep learning. Next, we will talk about this traditional deep learning based methods and what is the how this deep learning can be improved due to this blockchain application, or this blockchain improves the deep learning performances. If we look into this traditional deep learning based methods, so these traditional deep learning based methods store the data or in the cloud, manage the data, as well as train the algorithm. Am I audible to everyone?
Yes, sir.
Yeah, okay, fine. Thank you. So if we look into the traditional deep learning based methods, it is based on the cloud based servers, and this able to store the data. It can able to manage the data, as well as that we are able to train these algorithms. So if you talk about a different approach of this deep learning, that is telehealth, telemedicine, and we can talk about these wearable devices which can collect the data and send it to a servers through a trusted edge servers. So when we are talking about these wearable devices are present over the patient, and this can collect different information like temperature or blood pressures or heart rate, pulse rate, oxygenation levels, and it will send to the server through the edge servers. So that means we are talking about many or large amount or the variety of data or various data. Method which uses a centralized server, and due to this centralized server there is a single point failure. So that means we can say that at a single point, if there is some failure occurs, the total system collapses. So the data is very important for this deep learning concept, or that is for the use of this deep learning. So if we look into this blockchain and how if we use this blockchain in case of deep learning, it is a potential to handle the traditional deep learning problems. It maintains a shared ledger of data among the participants in a decentralized network. It enhances the robustness of the deep learning model, protect the data against different attacks. This is tamper resilient. So these are some of the advantages. If you look into the other advantages of this blockchain, as already Professor Vidyasagar told in previous classes, this is data immutability, transparency, security, provenance, traceability, as well as operational visibility. So decentralized and peer-to-peer architecture of blockchain helps to provide such advantages. So this blockchain uses smart contracts, which makes the business process on the blockchain platform can be automated using a self-executing smart contract that eliminates the role of third parties in executing the service. So it ensures data integrity. We'll take one example of a healthcare system. Suppose I am using a wearable healthcare device which continuously monitoring my heartbeat, or it is continuously monitoring my the ECG signal that is generated from this heart, which is nothing but the electrical activity of this heart function or heart functionality. So need not to send this ECG signal continuously from this wearable sensor to the server. Whenever there is some abnormalities or some arrhythmia occurs, or there is some changes in this heartbeat or heart rate or the ECG signal, that to be sent to the server. So that means if here it is a condition, it is called a smart contract that is called if-then conditions, which improves thus deep learning performances by the help of this blockchain. So as Professor told yesterday, we are talking about different types of blockchains, and these different types of blockchains have been used in deep learning concepts. That is private blockchains, public blockchains, as well as consortium blockchains. And these various type of blockchains have been used for the different type of applications. If we look into this machine learning models, which is created and trained by the different entities, so blockchain doesn't have a duplicate of data. Blockchain don't have a missing data. So now, as this blockchain has the advantages of not having duplicate data or missing data, it necessitates of this AI-based models to improve, or this is one of the most important criteria that improves the AI-based model performances. So blockchain with machine learning has the advantages that provides data authenticity assurance, data usage management, audit trials, as well as introducing new values to the business processes through a automation enabled by smart contracts. So here we'll talk about this blockchain-based deep learning frameworks, and how we'll discuss about this deep learning frameworks, blockchain-based deep learning frameworks. So I have divided this total, that means this presentation into different categories, that is based on parameters, based on strength as well as weaknesses. We can compare both these parameters as well as strength and weaknesses, and we can look into some of the research challenges that where this blockchain as well as deep learning has been used. So if we look into this background of this blockchain technology, as already Professor told in last few days, so this blockchain basically stores the information such that are difficult to modify by the hackers, change and delete or manipulate. This uses a decentralized technology, consists of many nodes for verification and transactions, ensures the correct link to the newly generated block. Newly added block is propagated to all participating nodes for data consistency. Smart contracts that execute when the condition is reached, which reduces the risk. So if this blockchain characterizes by data immutability, what are the information healthcare sector? There are two things we are getting. One is called health records. What is electronic health records? This data are related allergy, etc. This is thoughts. That means this the electronic health records as well as personal health records of the patients. Health record as well as personal health record systems contain some that is related to diagnosis of a particular disease, medications about a particular disease, that is sorry, the internet was disconnected. Just a minute. Let me look into that. Yes. Am I audible now? Yeah, fine. Sorry for the inconvenience due to internet problem. It was disconnected. So we are talking about this blockchain in healthcare. So here we are talking about electronic health records as well as personal health records. So whenever we are talking about this electronic health records or that is and personal health record system that contains the information that is related to diagnosis of a particular disease, medication about the particular disease, allergies, disease history. When we are talking about the disease history, that from how many years or how many days this disease has been occurs, or like cancers, or test results, what are the test results by different test processes. So this electronic health record contains the data about a patient, that means all clinical data, hospitals, test center data, laboratories or health organization data. If we look into the patient health records, this is patient-centric and maintained at a private environment and can be shared with others by the permission of the patient. So if we'll talk about the patient-centric data, so what is the age, what is gender, which group, or this. So this patient-centric data is maintained with a local environment, or that is called a private environment, and can be shared with the permission of the patients. So as this blockchain is used in healthcare to improve the performances. So management through a self contracts. So whenever a record is required by some other clinic, other doctors or doctors from the other hospitals, that can be used. Appropriate technology needs to be implemented for efficient management. Blockchain in healthcare has the advantages to reduce the data size as well as avoid the single point failure. One of the best example is called this COVID-19 pandemic. So this COVID-19 pandemic, what are the information it is keeping? So it is keeping the information about the patient, that is patient details, the address of the patient, male or female, what is the age of the patient, which age group it is coming, which location this basically it is coming from, and if we look into this lab reports, whether this he is COVID positive or the patient is COVID positive or COVID negative, and if it is COVID positive, then he has to be go for a quarantine, or if many people are COVID positive at a particular region, so this will give rise to a pandemic situation, or that means so different personnels, like some government personnels has to look into that. So how this blockchain is used in case of healthcare is one of these example that we are talking about. So now we'll talk about that how this deep learning will help, or this deep learning and blockchain will help the improving the performances. So here we'll talk about some slides related to deep learning. Then we'll talk about the challenges. If we look into this deep learning, first we'll start with our discussion about this learning. So this learning process was developed by Ambrose in 2010, and which represent the process that leads to change, which occurs as a result of experience and increase the potential for improved performance as well as future learning. So that means when we are talking about this learning, each time we are learning something that leads to a change, and which results as an experience. Experience says, I'm giving a very nice example. Your parents have told many times, or that is A, that means you are learning A during your childhood, but this A can be represented in many ways. So whenever a new representation of this A or type of A comes, we can able to identify. So this basically comes from this experience, and it increases the potential for improved performances as well as the future learning. So each time whenever we are learning, the performance of the system, the performance of this model is improved, and this basically reflected in our future learning processes. So this learning is not a new concept. If you look into this learning, it was that is basically represented to the neural network as well as the artificial intelligence. So if we look into this artificial intelligence, basically this represents how the computer can able to think. So we are introducing the intelligence into the machines. The machines can able to behave like the human beings. The machines can react like the human beings. So that is known as the intelligence is introduced into the machines. So basically computers can able to think like the humans, and the effort to automate the intellectual task that is performed by the humans. So this artificial intelligence is mainly depending upon these neural networks. That means the different connection of these neurons. If you look into the interconnection of these neurons, this will look like an artificial neuron, so which basically mimic the action that is found in the human brain. So this neural network concept is nothing but a artificial representation of this dendrite as well as axons, cells as found in case of our human brain. So next topic that is called neuromorphic computing, which inspired by the biology and implement the theory of human brain modeling by the neurons as well as by the help of synapses. So neuromorphic system provides a unique as well as a novel solution to this artificial intelligence. If you look into this machine learning concept, that ML, or that is known as the machine learning, which basically used to changes in a system that enable it to do some task or task drawn from the same population more efficiently as well as more effectively in the next time. So this was given by Simon in 1983, which tells about the changes in a system that enable to do some task or tasks drawn from the same population more efficiently as well as more effectively in the next time. So how we can achieve this by the help of this deep learning? So which that is to improve the system by acquiring new knowledge, acquiring the facts as well as the new skills, by adapting its behavior, that is solving problems more accurately as well as more efficiently. So this machine learning concept basically aims to study of the algorithms that improve their performances at some task and with respect to some experiences. So whenever we are talking about experiences, the performance has to improve for the future learning. So optimize the performance criteria using some example of data, or that is called your past experience. So this machine learning concept is based on two things. One is called the role of statistics, which basically tells about the inference from the samples or inference from this data, and the role of computers. So the computer plays a very vital role, and which looks into these algorithms to solve the optimization problem, and it represents the evaluating the model inference. So why you will study this machine learning concepts? Because it provides a better computing system that are too difficult or expensive to construct manually. So that means it gives rise to the knowledge engineering bottleneck. And this machine learning can automatically adapt and customize themselves to individual users. How we are doing in case of a personalized news or mail filter, personalized tutoring. So we can discover new knowledge from the large set of databases, that is data mining, market basket analysis, that is whenever we are going to the supermarket, basically the diapers and beers are kept at the same place, that is market basket analysis. Medical text mining, that is how this migraines of calcium channel blockers to the magnesium. So there are some related disciplines of this machine learning. If we look into the related disciplines of machine learning, there are numerous disciplines, that is artificial intelligence, neurobiology, data mining, probability and statistics, information theory, numerical optimization, computational complexity theory, control theory, adaptive psychology, or developmental or cognitive, linguistic, philosophy, etc. So if we look into the type of learning, the type of learning is mainly divided into many categories, but here I have summarized a few of them. The first one is the very basic type of learning, that is called induction as well as deduction. If you look into the induction, basically this is tells about the observation to idea. So what is observation to idea? That is, if we expand this observation to idea, there are certain theories, hypotheses, patterns as well as observations. So we can say that some theory to observations. If we look into the deductions, this is nothing but the idea to observations. That is theory, hypothesis, observations, and after that we are talking about the confirmation. So here it is theory to confirmations. Rote learning, that is nothing but a memorizations, advice or instructional learning. Learning by example or practice, how basically all the students, all the childs are basically learning by the help of examples. Learning by analogy, that is a transfer learning, that means some learning concept is used or some algorithm is used for the kind of, or for learning the other examples. Discovery learning, we'll talk about this transfer learning more detail in later slides. So if we look into this varieties of machine learning concept, this is concept learning, clustering algorithm, connectivity algorithm, genetic algorithm, explanation based learning, transformation based learning, reinforcement learning, case based learning, macro learning, evaluation functions, cognitive learning architectures, constructive induction, discovery systems, knowledge captures, etc. So these are some few of these examples of these varieties of machine learnings. So as I have discussed, this machine learning algorithm can able to learn from the data. So that means already we have discussed that the data are very numerous. That means varieties of data or numerous kind of data are coming to this machine learning algorithms. So machine learning can able to learn from the data, and basically we are requiring a computer program that can learn from the experience with respect to a particular task. So that means for a particular task we have to learn. That means we have to fulfill a particular task. So whenever we are performing a task, this performance has to be improved with respect to the experience. That means each time whenever we are doing or performing a task, the performance has to improve with respect to the experience. So learning is attaining the ability to perform a task. So how we can able to attain this ability to perform a task? So a robot able to walk. So here I have given one example of a robot able to walk. So walking is the task. So in this case, we can say that how we can able to make that robot to work manually. That is nothing but we can able to do some programming. So in this case, one is called the task. So working is the task, and program the robot how to work is known as the learning. So I hope it is clear to all of you. So learning is nothing but the attaining the ability to perform a particular kind of task. So yeah, so here we are talking about the data. Another is called the experience, and where we'll get this experience. This experience plays a very vital role, and this experience that we are gathering from this databases itself. So we know that the database is very numerous, and we are collecting the data by different sensors, different weight or different or we are collecting different kind of data, image data, time domain data, etc. So and we are getting or gathering these experiences from this data. What kind of experiences are allowed during the learning process? Here I have taken one example that is called the Irish database, which was developed by Fisher in 1936, and which is consists of 150 different Irish plants. And if we look into this database is divided into different categories based on certain features. And these features are nothing but the sepal length, sepal width, petal length, as well as petal width. So these features have been used for categorizing these 150 different Irish plants. So that means we can say that the experience that we are gathering is from this databases itself. So if we'll compare these machine learning algorithms are mainly classified into 3 categories or 4 categories. So here I have made into 4 categories: supervised, unsupervised, semi-supervised, as well as reinforcement learning. So we'll talk about this machine learning categories, that is supervised, unsupervised, semi-supervised, as well as reinforcement learning. So what is supervised learning? Basically, in case of supervised learning, there is some annotations are present. This map the input data to a known target. So that means what exactly this known target? In this case, the annotation is basically present, or we can say in another way that it involves of observing several examples of a random vector x and an associated value of vector y, and learning to predict y from x. That means what exactly we are calculating? We are estimating the probability of y for a given input vector that is equal to x. So that means learning to predict y from x. So y is, if we'll talk about this y is being provided by the instructor who shows the machine learning system what to do, and useful for a large amount of data. And this basically used for many kind of applications, that is supervised learning, that is optical character recognition, speech recognition, image classification, language translations. And if we'll take a very realistic example, that means the childhood as well as parent-teacher relationship. So that means how the child basically learns the things from the parents or the teacher. Basically, teacher or the parents are nothing but tells about a particular context or tells about the particular thing many times, and the child has to repeatedly understood that thing many times, and after that he can able to recognize the things. So the childhood parent relationship can be represented as a supervised learning, and in which the parent and teacher is nothing but we can say or perform the work of your annotations. So this is about the supervised learning. Next we will talk about this unsupervised learning. What is unsupervised learning? So this is without the help of a target. Am I audible to everyone? Am I audible?
Yes, sir. Yes, sir.
Yeah,
Continue, sir.
Yeah. So next we'll talk about this unsupervised learning, which is without the help of a target. There is no annotation is present. As there is no annotation is present, so we have to get this information from this data or this distribution of this data. So what exactly this unsupervised learning? This unsupervised learning without the help of target or observing the different instances of the random vector X and aiming to learn the probability of a distribution, that is the probability of a distribution that is X. So experience a data set containing many features, then learn useful properties of the structure of this database. So if we'll take about bread and butter of data analysis that is used in case of data compression, data denoising. So this is a kind of unsupervised learning. This one of the most important application of this unsupervised learning is nothing but the clustering. That is called we can group certain similar things into a same cluster or same group. So this is basically used in case of dimensionality reductions. So one of the best realistic example that is nothing but how these adult peoples are behaving. So adult means basically during our childhood, everything we are asking to our parents or to our teachers. That is called supervised learning. During our adult, we think that we have learned and we have grown up, and we take the decision by looking into the surroundings, by looking into the situations. So this is a kind of unsupervised learning. Next is called the self-supervised learning. It is a kind of supervised learning without human annotated labels. That means there is no human annotated labels are present, but still they're involved some generated from this or that labeling is generated by the help of heuristic criteria or heuristic algorithms. So one of the best example of this autoencoders. These autoencoders are well-known instances of self-supervised learning where the generated targets are the input or that is unmodified. So a self-supervised learning can be just a minute. Supervised learning or supervision comes from this future input data. So one of the best example is nothing but the Gmail, or we are talking about the WhatsApp. So whenever we are writing certain text or messages in the WhatsApp, what will be the next word that is to be typed that will be predicted from this previous text or the previous words. So these are the things that is nothing but the self-supervised. In case of self-supervised learning, the new frame or that is the new word can be predicted from the previous samples of the previous words. Next is called semi-supervised learning. In case of semi-supervised learning, a small portion of a labeled examples and a large number of unlabeled data is present. So that means a few labeled examples are present and large number of unlabeled data is present. One of the most popular example of generative adversarial network. And basic generative adversarial network consists of a generator which generates some fake data as well as a classifier, which can able to classify the fake data from this real data. If we will compare the difference between self versus semi-supervised learning, the similarity between both of them, that they don't entirely depend on manually labeled data. Self-supervised learning model depends on the underlying structure of the data to predict the outcomes. It involves no labeled data, and autoencoders is one of the best example of this self-supervised learning. In case of semi-supervised learning, a small amount of labeled data is used, and one of these popular example is called the GIAN. Next is called the reinforcement learning. What is this reinforcement learning? This don't experience any kind of fixed databases. Basically, it is used in case of feedback-based machine learning systems. So, what exactly is this? Suppose I have an automatic driving car. And when I'm talking about an automatic driving car, so the automatic driving car has to take a decision based on this environment, based on this road condition, based on this condition of the traffic, etc. That means the self-driving car takes the input from the environment, and based on that input, this driving car take an action such a manner that the reward is get maximized. So this is a kind of a feedback system, or it uses a feedback loop into the system to maximize the output. So if we look into this reinforcement learning, it comprises of an agent that basically receives the information about its environment and getting a feedback system and its experience, and learns to choose the action that will maximize some reward. So in this case, we can say that there is one environment is present, there is a feedback system is present. So there is a feedback from the environment to the agent, and the agent has to take an action so that reward is get maximized. And the most popular example is called self-driving cars, robotics, resource management, etc. So one of the best real life example is how behavior basically depends during our professional life. Basically, during our professional life or in our situation, that means in academic or industries, basically a person has to behave in such a manner that their higher authority is always happy, or the situation will be always in his control. So that means what exactly this person or this particular person is doing? He's taking some input from the surroundings, from the environment, and based on this input, he has to take an action, he has to take a decision in such a manner that everybody got happy with that, or the situation is in his control. There is no ops, or there is no abnormalities, or we can say there is no fluctuation in the system, it is stable. Next, we'll talk about this transfer learning. It uses a transfer of knowledge from a related task that has been already pre-trained. This improves the learning process and useful for reduced amount of data. So learn the features of any labeled instances, even with a scarce of training data. That is, one would train a CNN on a very large data set, that is ImageNet, and then fine-tune the CNN on a different data set with a different better features. So here we have talked about the different type of learning, that is supervised, unsupervised, self-supervised, semi-supervised, reinforcement, as well as transfer learnings. So these learnings to understand that how these learnings are basically different. So I hope it is a nice time to stop or take a break for 15 minutes. So we'll again meet after 15 minutes. If anybody has any questions, please write in the chat box, or we can have a discussion in the afternoon. So we'll take a break. Thank you.